All right, for this next problem, we want to find the area and the perimeter of this triangle. So we're going to start first with finding the perimeter, because it's going to be a lot simpler. And then I'm going to come up with kind of a fun way to find the area of this particular triangle. So first, let's start with finding the perimeter. So if I notice, I don't have any length measures, which I would normally use to just add this up, which is why I need to use the distance formula, right? The distance formula is this nice little formula that's going to give me the distance between any two points. And you guys should have learned that in your geometry class. The teacher may have even talked about how it's related to the Pythagorean theorem. So let's get started. To find perimeter, we need to find the lengths AB, the length BC, and the length of CA, right? We need to find all of those lengths, and then we add them all up. That gives me the perimeter. So I'm going to go ahead and do my work up here. So let's start with the distance from A to B. All right. So according to the formula, I have the square root. I take the differences of the x's. So you can see we have 2 and 8. So 2 minus 8 squared plus. I take the differences of the y's. 4 and 12. So 4 minus 12 and I square it. Then according to PEMDAS, I have to do what's in the parentheses. 2 minus 8 is negative 6 squared. 4 minus 12 is negative 8 squared. Negative 6 squared, that's negative 6 times negative 6, is just 36. Negative 8 squared, that's just negative 8 times negative 8, it's going to be positive 64. And 36 plus 64 gives me 100. So the distance from A to B is 10 units. So now I figured out one of the lengths. Guess what? I got to do that 2 more times. All right. So we got to now find the distance from B to C. So I can figure out what the distance or length, they might call it either of those things. I'm going to take the square root of the differences of the x's. So I have 8 minus 24 squared. You can also write it 12 minus 8 squared. It's not going to matter. Differences of the y's. 12 minus 0 squared. All right. 8 minus 24 is negative 16. 12 minus 0, that's easy, 12. Negative 16 times negative 16 gives me 256 plus 144 gives me 400. All right. What is the square root of 400? 20. So the distance from B to C. Now these are working really nice. They don't always work that nice, right? Sometimes you're going to have decimals, and so you'll have to follow what they tell you on the EOC, whether they want you to go to the 100th place or the 10th place or the thousandth. They're probably not going to say thousands. It's probably going to be 10th for ones place or hundredths. All right, so we now have 2 of the sides. I just need 1 more. So we're going to do the distance formula 1 more time so we can figure out this length here. So the distance from A to C. All right, differences of the x's. 2 minus 24 squared plus 4 minus 0 squared. Differences of the y's. This is going to be negative 22 squared plus 4 squared. All right. Negative 22, that's going to be negative 22 times negative 22, which is 484. Remember, it's going to be positive because a negative times a negative is a positive. We're going to add 16 to it. So we get 500. And let me put my little equal signs here. And the square root of 500. Let's see, is that one going to work out nicely? No, it didn't work out nicely. Boo. So, it's okay. It's about, hold on, let's see, square root of 500 is about 22.36. I'm going to go to the 100th place. 0.36. So that is going to be the distance here. So 22.36 units. I thought they were going to make them all nice. They did not. Alright, so now what do I do to get the perimeter? Add up all my sides. So the perimeter of this triangle is going to be 10 plus 20 plus 22.36. And I get that the perimeter is 52.36 units. Cool? Alright, so now let's see if we can figure out the area. Now this triangle is a tough triangle because I don't have a height. And let's remember that the, what's it called? The formula for area for a triangle is 1/2 base times height. And that height has to go straight down, making a 90-degree angle with its base. And I do not have that with this. So if you have a situation on the EOC, which might happen, then you can't just figure out, right, the distances like we did here and then plug them in. If you do, amazing, do that. But in this case, they don't have that. So I'm going to do something a little nifty here. I am going to make a rectangle on this grid. I'm going to make a rectangle on this grid so that I can basically find the area of the rectangle, and then I can subtract away the pieces that I don't want. Right? So here I have made a rectangle in red or pink or purple, whatever this is, and I can actually find the area of this entire rectangle. So let's see. It looks like this goes up 12 units, so this is going to be 12. That's the distance from here to here. And it looks like this distance is 22, right? So the area of a rectangle, so this is for a triangle, the area of a rectangle is just length times width. That's the nice thing. So the area of this rectangle is going to be 12 times 22, which is 264 units squared. Okay, so what that means is if I were to count out all of these little squares in here, there would be 264 units. And if you don't believe me, you can do it. I am not going to do that. Okay, so we know the full area, and we want this piece inside here, right? We want all of this. So what we're going to do is we're going to take away the area of these guys out here, and that's going to give me my full area. So let's look at this triangle here. So this triangle, I can see, does have a 90-degree angle, so I can make this length and this length the base and the height. That's what's nice about this. So let's count how many this is. So this is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 4, 5, 6, 7, 8. Yep, so there's 8 units there from here to here. There are 1, 2, 3, 4, 5, 6 units here. So this is going to be 8 times 6 divided by 2, right? Half of that. So this is going to be 24 units. So we're going to take away 24 from this, okay? Now we're going to find this guy here. So this goes from 8 to 24. So 24 minus 8 gives me 16. So this length here is 16. Right? You could also have said, oh, the whole thing is 22. This is whatever. So this is 16. And let's find out what this is. This goes from 0 to 12. So 16 times 12 equals 192. I'm going to divide it by 2. And we get 96 units squared. I know this is not beautiful, but oh well. Okay? Now the last triangle, we go from 0 to 4, so that's going to be a distance of 4. And we go from 2 to 24, that's going to be a distance of 22. So this is going to be 4 times 22, which is 88 divided by 2. 88 divided by 2, which gives me 44 units squared. Okay? So now what I'm going to do to find the area of the shaded region, let me shade it a little bit brighter, we're going to do 264 minus the sum of the areas that we found, right? So that's going to be 24 plus 44 plus 96. So 264, let's see, minus 24 plus 44 plus 96. Put it in parentheses. And we get that the area of this guy is 100 units squared. Okay, because that's basically, if I were to count all of the little triangles in here, they would give me 100 units squared.